My students, can you hear me? Its topic is software reliability. I hope everybody can see this window, this screen on the whiteboard. Is that clear to everybody?
Yes, ma'am.
So we have studied about in the last lecture the topic we covered was related to testing, and we have covered every kind of testing. Now we'll move towards reliability, and we'll tell you the difference between software testing and reliability and quality assurance. All the quality assurance methods that we apply in software engineering. We'll study all these methods too. My question to everyone is that uh, everybody is now clear with the numerical part related to testing, white box testing and black box testing. Is that clear to everybody, or there is issue? You are able to understand the concepts related to manual testing in white box as well as in black box testing. So moving further, software reliability. Still students, please come on time. Still students are joining this session. So, whenever we talk about software, we talk in terms of three phases in the life of every hardware component, that is burn in, useful life, and wear out. So, we know that in the hardware, we can say we have three phases. First is burn in, useful life, and the third one is wear out. Every product wear out with the time. So we know in burn-in phase, failure rate is quite high initially, and it start decreasing gradually as time progress. During useful life period, failure rate is approximately constant, and failure rate increases in wear out phase due to the wearing out, um, components aging of component. The best period is useful life period, and we know what is useful life period. uh, Kindly be on time, class. So uh, the shape of this curve, basically the wear out phase is a bathtub curve, and is usually known as bathtub curve. So I'll show you the bathtub curve here just to show hardware reliability, yeah, yeah, in the computer system. So that is given by here it is failure rate, and here we have time. And this is basically the curve is like this curve, bathtub curve. So we can say this is the burn in phase, burn in, burn in. Whenever we are making using creating that hardware, useful life, useful life, and the last one is wear out. Because we know that with the passage of time, every kind of hardware gets wear out. So this curve is called bathtub curve and very much popular in hardware reliability. So with passage of time, this failure rate increases, and you can see here in the case of useful life, the failure rate decreases, and again it rises, and it comes out to be zero with passage of time, and again it increases when it usually got wear out. So that is the we can define the hardware reliability. But we do not have wear out phase in software. So the expected curve for software is, uh, we can say this is the expect curve or related to hardware reliability, not a software reliability. I'm changing name here just because for your understanding. Otherwise, we'll discuss software reliability. We have no nothing to discuss in except this bathtub curve in the hardware reliability. The main topic is software reliability. So whenever we talk in terms of software reliability, the curve is not exactly the bathtub curve. It is like a downward kind of curve, that is software reliability. The curve is, the first is testing phase, then it's a useful life, then is obsolescence. Obsolescence means the product is no more in use, or we can say it gets obsolete. So the curve is like this. So this is a curve, and this relates to testing phase. After testing is implementation phase, and the software is being used. Or to say this is a useful life, and next is obsolescence. Spelling might be wrong. You can check that spelling. Uh, I request everybody in this class to please be on time. I'll not allow anybody in next lecture if he or she is coming late in the class and messaging me again and again to join that class. So you can see here this is the failure rate and this is time. Failure rate versus time. So the failure rate is maximum you can see and it reduces with the testing phase. In the useful life, it is we can say minimized, and here in the case of obsolete, the failure rate becomes fixed, and we say the software is now obsolete. Obsolete. It is no more in use. So this is basically the concept behind the software reliability. Software may be retired only if it becomes obsolete. And we know we throw the software, we don't use that software when we feel that it is of no use. Some of the contributing factors uh, in being a software in the form of obsolete state is that first is change in environment. Change in environment. So first is change. Why the software fails? We can say change in environment. Next is change in infrastructure and technology with time. Change, change in environment, change in infrastructure or technology with time. Or we can say on major change in requirements, we can say change in requirement with time, change in requirement We have set requirements for particular software. With passage of time, we realize these are not our actual requirements. Increase in complexity in the system, in the manual system, increase in complexity. Complexity बढ़ गई है. Software is very simple. It is not able to support that complexity which comes with passage of time. You can understand that in every system, in every manual system, we make some kind of software. But with passage of time, that manual system that we have converted or shifted to some kind of software, it became complex. But we feel that some of the functionality that our software was supporting earlier, and there is the scope of new functionality too. But we are not able to change that particular software that we are using. So we usually feel like we should throw that software, or this software is obsolete, and we can move towards making a new software. Or we can say maintenance is we can say extremely difficult to maintain. We The software is obsolete just because it is extremely difficult to maintain, or we can say deterioration in structure of the code. Deterioration in structure of the code. Deteriorate हो गया, खराब हो गया with passage of time code का. There may be possibility of slow execution speed. जो आपके पास सॉफ्टवेयर है वो ऑब्सोलीट क्यों हो गया, क्योंकि वो बहुत स्लो काम कर रहा है. स्लो execution speed may be the reason. Or we can say because software are become obsolete because of the poor UID, user interface design. So these are some of the reason why a software fails, and we say that it is no more reliable now. So what is basically a software reliability? In the We can say it is the ability of the system or component. Software reliability is basically an ability of a software system or component to perform its required function under stated conditions. Ability of software. Ability of software or a component to perform required functions under stated conditions. Stated conditions for a specified period of time. For a, why I'm writing for a specified period of time? Because we can say with time this software is no more reliable. So reliability is totally dependent upon time. We cannot ignore the phase called time. Reliable है, आज है, कल नहीं है, परसों है, फिर नहीं है, और एक टाइम है, it is now obsolete. So this may be the case. So ability of a software or a component to perform required function under stated conditions for a specified period of time defines a software reliability. We know that every kind of software has failures and faults associated with it. So we know what is failure and what is fault. We know the difference between failure and fault. So fault is something uh, is a kind of defect. A fault is a defect in the program that when executed under particular condition causes a failure. So fault is basically a defect. And if this defect is executed in particular condition, it will lead to failure. If a failure occurs with the time, if a failure occur at a particular time, we say that this software is no more reliable. So the execution time of a for a program is the time. Basically, what is the execution time? Execution time for a program is the time that is actually spent by a processor in executing the instructions for of that program. The second kind of time is calendar time. It is Gursevak Singh Ankit, please be on time. Next time I will not allow. The execution time for program is the time because it is executed in particular condition. So we should know the execution time. It is a time spent by a processor in executing the instructions of that program. The second time is the calendar time, and it is familiar time that we normally experience in making a project. We know what is calendar time. So we should know the difference between the execution time and the calendar time. So there are four general ways we characterize failure occurrences in time. So four general ways for characterizing failure occurrences in time. Time of failure. Four, four general ways of characterizing what failures. Failures occurrences. Failure occur हो रहा है. In which time? किस time पे हो रहा है? Time of failure. We can say एक क्या होगा? Time of failure. कब हुआ था failure? Or we can say time interval between two failures. This is also time. Here one failure is occurring, here one failure is occurring. So time interval between two failures. So we can say time interval between two failures. Or we can say cumulative failure experienced up to a given time. पूरा cumulative time कितना है? That we can say cumulative failure experienced. Cumulative failure experienced up to a given time. Up to a given time. And or we can say failure experienced in time interval. I'm writing fourth here. Failure experienced in time interval. So we can say failure occurrences, failure occurrences in time can have particular failure time, time between two failures, cumulative failure or experienced up to a given time. मैं कहती हूँ 9 बजे तक कितने failures थे, cumulative failure experienced, that should be a cumulative sum. We can say failure experienced in time interval. I define the time interval and note number of failures that we can have in that time. So these are the we can say a ways of characterizing failure with respect to time. So there may be any number, we can define that number, how many failures are occurring with this respect to how many time. So we also see not only the failure, we also see in the software reliability, the failure intensity, and failure intensity define the reliability of the system. So we can say failure intensity Failure intensity and reliability typically vary during the test period. We can show that also. So failure intensity may decreases, but when failure intensity decreases, reliability increases. So it is an opposite curve. I will show you that. If suppose this is the curve for failure intensity in a software with respect to time. So the reliability will be like, we can define the reliability on the other hand side. This is the reliability. This is the failure intensity. So failure intensity curve is like that with respect to time. The reliability will be this. If the intensity decreases, reliability increases with time. So this is the relationship between failure intensity and reliability. Why we study reliability? Basically, software reliability. There are many reasons we study software reliability. You can use software reliability measure to evaluate software engineering technology quantitatively. So basically, software reliability measures are used to evaluate software reliability measures are used to evaluate what to evaluate engineering technology quantitatively. It offers you the possibility of evaluating developed status during the test phases of the project. So software reliability measures will offer you, ये question आ सकता है, why we measure the reliability of software? It offers you the possibility of evaluating development status. Offers you the possibility of evaluating development status, during the test phases of a project. हम जब टेस्ट फेजेस अप्लाई करते हैं, we can see evaluate the development status during the test phases of a project. So other reasons uses, or we can say the uses of software reliability measure include to monitor the operational performance of software and to control new features added. So there may be a monitoring, we can say the third concept may be use of software reliability measure is to monitor the operational performance of software and to control new features added and design changes made in the feature operational performance and to control new features, new features added and design changes. And design changes. design series. When you do software reliability, you get a quantitative understanding of the software quality. So it also tells you about the quantitative, we can say the quantitative analysis of quantitative analysis of software quality, software quality, and we can see the various factors influencing it, and various factors influencing the software quality. So we can say software quality is measured by the reliability. If it is reliable, it is more quality assured. So we can see. So we can say but if we talk that software reliability measure the software quality in a quantitative way, then what is quality? What is software quality? So we can say a software quality can be defined in different ways. Like if your software quality is good, or we can say if it meets, or we can say it is according to the conformance of requirement. Conformance of requirement. जो requirement थी, जो requirement वो fulfill कर रहा है. So we'll say the quality is good because it is conforming to our requirements. For some people or for some people who are developing projects, they say fitness for the purpose for which the software is developed. Fitness for the purpose. मतलब क्या है? It is fit जिस पर्पस के लिए डेवलप करें. More the fit the project is, more it has a software. We can say good quality the software has, or we can say defined in the terms of level of satisfaction of the customer. If the customer is satisfied, he will say, or she will say the quality is good. So these things like conformance to requirement, fitness of the purpose, and level of satisfaction can define the software quality. But if we define in terms of, we can say, uh, uh, engineers or researchers who have researched on these things, so we can say the reliability is dependent on correctness. The reliable system should have the following attributes. Which attribute, if the system is reliable? Which attribute? It should have correctness, correctness for a system to be reliable, consistency and precision, and precision. Uh, Robustness should be there. We can say simplicity and traceability. The system is traceable, it is simple, robust, it has consistency and precision, and correct. The system will be called as reliable. So, if we define the software usability, in terms of usability, this is reliability. If I replace this term with usability, what is software usability? What attributes define software usability? So, in case of software usable है कि नहीं है? It should have accuracy, as attributes. What will be the attributes for software usability? First would be accuracy और reading. तभी हम उसको यूज कर पाएंगे. Accuracy. Next is clarity and accuracy of documentation. Clarity and accuracy of documentation. Uh, Conformance of operational environment. Conformity. Conformity of operational environment. You can say completeness should be an attribute. Completeness. Only then we can use it is usable. Efficient. Testability. We are able to test that system. Testability. So these attributes should define the software usability. Next is when do we define the software maintainability? It includes software maintainability. It includes the attributes like first is accuracy and clarity of documentation because we are to maintain that software. So we should have the documentation of the software that was developed 10 years ago or 15 years ago or 20 years ago or 5 years ago. Because software can be only be maintained if we have a software as well as its documentation and documentation should be accurate. So accuracy and clarity of documentation, modularity should be there. You should be able to understand the various modules for maintaining that software. We are able to read it, read those things, readability should be there, and simplicity. It should be able to simplify. We are able to understand the concept. Simplicity. Okay. So these define the maintainability. These attributes define the maintainability. Now there is a term called software adaptability. So from the adaptability, adaptability, we mean whether it is able to adapt the new environment. So it can only be possible if it is able to modify. We are able to modify the software. Only modifiability is one such attribute that should be if the software is if we are able to modify that software, we say we can this software is adaptable. Or we can say it has the option of expandability. We can expand that software expandability. ला सकते हैं कुछ new features डाल सकते हैं. Only then we say this is adaptable to the new environment. And now last but not the least, portability. We are able to shift from one environment to the another environment or one uh, operating system to the another operating system. The software is portable. It is portable, it is adaptable to the new environment. So software adaptability comes with modifiability, expandability, and portability attributes. So I repeat in a simple language. Reliability is the extent to which a software performs it is intended function without failure. अगर तो कुछ failure नहीं है, without failure, it is performing intended operation. intended operation without failure. We'll say software is reliable. Reliable. Correctness. Correctness defined when software extent, we can say the extent to which a software meets its specification. So meeting specification means the software is correct. Next is from the consistency and procedure. Consistency, consistency and procedure mean the extent to which a software is consistent and give the result with to define the extent to which software is consistent and give results with precision. So we know these terms. We can say, suppose robustness. Can anybody define what is robustness? In anybody in the class? Robustness. कोई नहीं बता सकता. What is robustness? How we can define robustness? Nobody? What is robustness? कभी सुना है? The system is robust. हाँ जी, ये बोल रहा था.
Strong and healthy kind of.
I'm not able to hear you. क्या कह रहे हो आप? Anchal? I'll define you the extent to which a software tolerates the unexpected problem. Extent to which the software tolerates unexpected operations or problems and unexpected problems. हम कहते हैं system is very much robust. So that means it is able to handle and tolerate unexpected problems very efficiently. We'll say थोड़ा सा robust नहीं है. So that means it is not able to handle the unexpected problems that are coming. So we have simplicity. Simplicity is extent to which a software is simple in its operation, and will define traceability. Terms are have meaning. They are feel like they are related to each other. If I say traceability and usability, you people will not able to tell me the difference, but they are different. So traceability is the extent to which an error is traceable in order to fix it. So that is traceability. We can find the error or we can trace the error. So that should be there in the system traceability. And usability is extent of effort required to learn, operate, and understand the function of the software. So that defines the usability of the software system. Like we have accuracy. Accuracy is meeting specifications with the precision. We have conformity of operational environment that defines the extent to which a software is conformity of operational environment. Completeness is to extent to which a software has specified functions. And like we have efficiency, everybody know what is efficiency. The amount of computing resources and code required by software to perform a function is the efficiency. So maintainability is a term we can do of effort required to locate and fix an error during maintenance phase. That is maintainability. Testability is the effort required to test a software to ensure that it performs its intended function. So that is testability. So moving further, we have modularity. So modularity is uh, the extent or of ease to implement, test, debug, and maintain the software. We have adaptability, extent to which a software is adaptable to new platforms and new technologies. Modifiability. Modifiability is the effort required to modify a software during maintenance phase. So expandability is extent to which a software we can is expandable without undesired side effects. And portability is basically the effort to transform a program from the one platform to another platform, and that is portability. So these are characteristics, and these characteristics are associated um, with one or the other usability, and we can say maintainability and quality and reliability terms. So moving further, we'll have one rule here first of all, then we will do next part. Kindly answer these questions. Ma'am, if useful life reached zero, once then how it again start increasing due to network jam. So if useful life reached zero, it will never be a case that you will come towards a zero, because what I feel is the software may not be totally useful, may not be totally unuseful. ऐसा तो नहीं होगा भी totally unuseful है. There may be a condition that it is not up to that level useful that is required, and we'll say that is obsolete. So that is usability. ध्यान से पढ़ो पहला क्वेश्चन. Which of the following is not a phase of bathtub curve of hardware reliability? Useful life, burn in, wear out, or a time. Next is, how is the reliability and failure intensity related to each other? I am repeating these questions. Which of the following is not a case of bathtub curve of the hardware reliability? And uh, how is the reliability and failure intensity related to each other? Still, students have not answered these questions. There are students who have not responded to these questions. A large number of students have not responded yet. So I'm ending the poll here. Uh, Answer to these question is first is which of the following is not a phase of bathtub curve of hardware reliability. So the answer is time is not a phase in the software or in the hardware reliability. Or is reliability and failure intensity related to each other? They are inverse, they have an inverse relation. So this was the answer. I'm sharing your result. So moving further, we'll study the quality assurance standard today. That is in your syllabus, and that is ISO 9126. ISO 9126. This is a quality assurance standard. So this ISO 9126 um, has features associated like uh, reliability, portability, etc. Functionality, usability, efficiency, maintainability. So ISO 9126 includes the six features. Those are functionality. You need to check the functionality of the software. और conformance to ISO 9126 standard. मतलब कि अगर आप चाहते हो you want to achieve ISO 9126 standard quality assurance, it should be checked on functionality, reliability. Next is usability. Usability, efficiency, maintainability, and the portability. And portability. So these are standards that define the software reliability. We know functionality characteristics relating to achievement of basic purpose for which the software is being engineered. Reliability characteristic relating to capability of software to maintain its level of performance under stated condition for a specified period of time. We have usability characteristics relating to the effort needed for use and on the individual assessment of such use by stated implied set of users. So usability needed for use and on the individual assessment of such use. We can say the efficiency is the characteristics related to relationship between the level of performance of the software and the amount of resources used under stated condition defines the efficiency. And maintainability is characteristics related to the effort needed to make modifications including correctness, improvements, or adaptation of software to changes in environment requirements and function specifications that define the maintainability. And portability is characteristics related to the ability to transfer the software from one organization or hardware to software environment to another. So that defines the portability. So that is called ISO 9126 as it has six standard. That is why it is six six here that define the six standards of, because it is derived from ISO 9000 main category of quality assurance. It includes this quality assurance standard include all hardware kind of hardware and software. And for every kind of device, we use this ISO 9000 standard. This is a basic standard model from which ISO 912612 that was based on the following factors: functionality, reliability, usability, efficiency, maintainability, portability. So these should be there for achieving this ISO 9126 standard. Now, next is next quality assurance model is CMM. That is CMM, quality assurance model. CMM. That is CMM is called capability, maturity model. Capability maturity model. It has five levels, and first level is right here. All the levels here. First is called the base level. Draw in this form. So this one, two, three, four, five. So the first basic level is called the initial level. Initial level. This is initial. Next is number one level. This is number two level is repeated. Number three level is called defined. Fourth is called managed. Managed. And fifth is called optimized or optimized. Optimized. This is called optimizing. So these are the maturity levels of maturity levels of memory. Capability maturity maturity level. And these are the levels. What these levels define, first is um, initial, repeatable, defined, managed, and optimizing. Basic characteristics of these levels are, and what these levels do is, first is this table representing the various characteristics. This is the maturity level and the characteristics. First is initial. Initial is basically for ad hoc process. Initial ad hoc processes. Next is repeated. Repeatable basic subject management. Basic subject management. Next is defined. Next is concept definition. Next is management. That is concept maintenance. Next is optimizing. It is process control. So maturity level, initial, we deal with the adoption. In the repeatable basic project management, we define process definition, manage process measurement, and optimizing is process control. Study these things in detail. So these characteristics like ad hoc processes, these are the characteristics. So in case of uh, the key process areas, we can say uh, what are the various key process areas that are involved in those uh, levels. We'll study that. And first is um, the key process area. So in case of first level, this is the level one. Level one. There is no key process, no defined key process, no key. Repeat key processes. Key process. In the case of it deals with ad hoc projects that are not continuous projects. So that is called there is no key process area to deal with in case of initial phase, initial level. Next is the number two, the level two. The key process areas at level two focus on software projects concern. So this level two that is repeatable. This level two, it focuses on the key process areas is basically related to anything concerned with project management. Everything concerned with project management, whether it's controls or anything else like requirement management, software project planning. So I'll study that level two first. Uh, that is the repeatable level in detail. Level two repeatable. I'm writing level 2 here and its key process area. Level 2 is repeatable. Level 2 repeatable. It has key process areas. कौन से हैं? These are related to project management, software project management. Software project management is the characteristic, and the key process areas will be requirement management, requirement management, that is RM. This is one key process area. Other one is software project planning. Project planning. PP. Project planning. Next is software project tracking and oversight. Software project tracking and oversight. Next is software subcontract management or contract management. Software subcontract or contract management. Software contract management. You can write software management or contract management. Software quality assurance. This is key process area. PMO software quality assurance. We have software configuration management. The last one is last key process area is software configuration management. I'm writing here software configuration management. This is the process area. So requirement management, it establish a common relationship between the customer requirements and the developer in order to understand the requirements of the project. Software project planning, this is basically establish a reasonable plans for performing the software engineering and for managing the software project. Next is software project tracking and oversight. This is establishing adequate visibility into the actual progress so that management can take effective actions when the software projects perform and deviates significantly from the software plan. Deviates significantly from the software from the software plans. We need to see that also if it is deviating. Next is software subcontract management. This includes selecting qualified software subcontractors and managing them effectively. Software quality assurance provides management with appropriate visibility into the process being used by the software project and of the product being built. And software configuration management establish and maintain the integrity of the product of the software project throughout the project's software lifecycle. So that defines software configuration management. So these were the key process areas at level 2. Now the key process areas at level 3. The level 3 is defined. So in case of defined, what are the key process areas? These are level 3, that is defined. तो KPA key process areas क्वेश्चन यूजली यही आता है. What are the various key process areas in capability maturity model of different levels? So it includes this third level includes organization process focus, organization process focus. Next is organization process definition. Process definition. Next is um, training program. Training program. Training program. Next is integrated software management. Management. So first is organization process focus. So organization process focus establishes the organizational responsibility of software process activities that improve the organization overall software process capability. So it sees, establishes uh, uh, organizational, we can say this organizational responsibility, responsibility of course software process activities and that improve the organization overall process capability. In the organization process definition, they develop and maintain a usable set of software processes, assets that improve the process performance across the projects and provide a basis for cumulative long-term benefits to the organization. So this focuses on cumulative long-term benefits. Cumulative long-term benefits include this. Next is the training program. Develop the skill and knowledge of individuals so that they can perform their role effectively and efficiently. So that this is the role of the training program. Developing skill and knowledge of individuals. Developing skills and knowledge of individuals so that they can perform their roles effectively and efficiently. Next is integrated software management. To integrate the software engineering and management activities. Basically, it is to integrate activities, software engineering and management activities into a coherent, defined software process. Into a coherent, defined software that is tailored from the organization's standard software process and related process assets. So this was the third level. So before moving further, we'll have poll here and we'll do the next levels before after that. Kindly answer these questions. Which one of the following is not a software quality model? ISO 9000 McCall model, Bohem model, and ISO 9126. Not a quality model. Software quality model आपने ये बताना है. And the other one is How is software reliability defined? So whether it's in the form of time, efficiency, quality, or speed. So kindly answer these questions. Still, students are there who have not answered these questions. So ending this poll here, answer to these questions are: first is which one of the following is not a software quality model? So ISO 9000 is not a software quality model. Next is how software reliability defined. It is defined in terms of time. So efficiency is not there, quality is not there, speed is not there, it is time. So reliability is measured, defined in terms of time. So moving further, uh, next is key process areas at level 4. So at level 4, which one is that level? तो बता सकता है कौन सा लेवल था? लेवल 4, that is the managed level. So key process areas at level 4, that is the managed level. It focuses on establishing a quantitative understanding of the both software process and software work products. Focuses on focuses on which on establishing a quantitative understanding. Establishing a quantitative understanding of both the software process and the software work product. So, software process and software work product. So the key process areas are quantitative process management, KPS, KPS क्या होंगे? Quantitative quantitative process management. Number two, software quality. So Quantitative process management control the process performance. It controls the process performance. Quantitative process management. I'm writing here. It is control, but it controls process performance of the software project quantitative. Control process performance of software project quantitative. Quantitative. And software quality management. It develops a quantitative understanding. It develops a quantitative understanding of quality of the object. Of quality of object. Object software. Can you hear me? Students, can you hear me?
Yes, ma'am.
जब नहीं होता तो चैट कर दिया करो, मैसेज पे बता दिया करो. There is an issue. So next is the next level, that is the level 5, that is optimizing level. So this in this level 5, the key process areas cover the issue that both the organization and the project must address to implement continuous and measurable software process improvements. So the main of things in this, the key process areas include defect preventive should be there. Defect preventive. Process areas, technology change management. Next is process change management. Process change management. So key process areas, first is defect preventive. In the defect preventive method, key process area, it should identify the causes of defects and prevent them from recurring. So what are the causes, and we should prevent them from occurring. That should be our concern in case of level 5, that is optimizing level, and defect preventive should be there. Next is technology change management. This eh, you should identify the beneficial new technologies, like uh, there should be a technology change management system, like identify beneficial new technologies This includes identify beneficial new technology, that is tools, methods, and processes, and transfer them into an organization in an orderly manner. And transfer them to organization in orderly manner. Next is the third one is process change management. Continually improve the software process used in the organization. So it should, I'm writing here, continually improve. Continually improve the software processes used in the organization. Used in the organization with the intent of improving software quality. So this is level 5. Defect preventing should be there. Technology change management that include identify beneficial new technology. It should be able to adapt new technology tools, methods, and processes and transfer them to organization in an organization manner. And process change management continually improve the software processes used in the organization with the intent of improving software quality, increasing productivity, and decreasing the cycle time for product development. That should be there in the level 5 key process areas. Moving further, the the common features that are there in case of, we can say in this capability maturity models, मैंने तो उसके सारे levels और we can say the, and we have discussed all the key features here. But if we talk in terms of common features, in terms of common features, this includes commitment to perform. We can say the common feature of all levels. First is commitment, commitment to perform. Number two, ability to perform. Perform. Next is activities performed. Measurement and analysis. Verifying implementation. So, commitment to perform describe the actions the organization must take to ensure that the process is established and will endure. It includes practices on policies and leadership. Ability to perform is basically the precondition that must exist in the project or organization to implement the software process competently. It includes practices on resources, organizational structure, training, and tools are ability to perform. Next is measurement and analysis. Uh, it describes the need to measure the process and analyze the measurement. It includes examples of measurement. And verifying implementation means whatever you have implemented, and you should verify, you should have described the steps to ensure that activities are performed in compliance with the process that has been established. It includes the practices on management, reviews, and audits in the case of common features of the capability maturity models at all levels. So moving further, we have one poll here, and after that, new topic that is the ISO 9000. Answer these questions. The capability maturity model is a technique to automatically maintain the software reliability, improve the software process, or test the software, or all of the mentioned. Another one is software reliability matrix. Is a measure of the likelihood of that system will fail when a service request is made. So whether it's a probability of a failure on demand or rate of failure of occurrence, mean time to failure, or rate of failure occurrence. Still, students have not answered these questions. Kindly answer these questions. This will mark your class assessment. Uh, whether you are attentive in the class or not, as well as your the class response. Ending this poll after 20 seconds. So the CMM model is a technique to improve the software process, automatically maintain the software reliability, test the software. It is basically to improve the software process. But it, in the capability maturity model, the reliability is also maintained. So, and test the software is not there. So, improve the software process. Next is software reliability matrix is a measure of the likelihood of the system is being when a service test is made. That is mean time to failure. So these are the answers to your question. Moving further, next topic is ISO 9000. ISO 9000 is series of standards. It is a set of document dealing with quality system. It is basically a series of standards. Series of standards. Series of standards is a set of document dealing with quality systems. So it deals with quality systems, set of documents dealing with quality systems. that can be used for quality assurance purpose. Used for quality assurance purpose. Quality assurance purpose. ISO 9000 series is just not a software standard. It is series of 5 related standards that are applicable to a wide variety of industrial activities. So this set of standards deal with wide variety of industrial activities that include design development, that includes क्या क्या include हो रहा है design and development, production, installation, production, installation, and servicing. So this set of standard applies to design and development, production, installation, servicing. Within the ISO 9000 series standard, ISO 9001. Yes, ISO 9000 series have an ISO 9001, ISO 9002, ISO 9003, and ISO 9126. This ISO 9001 is applicable for software development industry. So this applies to ISO 9001 applies to so this standard applies to the software development. So when we do mapping between this ISO 9001 to CMM, so the mapping shows that what things are related in ISO 9001 and CMM because both are quality standard ISO 9001 and CMM. Both are quality assurance standards. And what are the main mapping between them is first is management responsibility. Both is there in both cases. Responsibility, quality system, quality system, contract review. Next is design control, design control, document control, purchasing, and supplied products, inspection and testing. Inspection and testing. I'm writing only the main. There are a lot of inspection characteristics that are common to both ISO and 9001 and CMM. Corrective actions, corrective actions, control of non-conforming product, inspection and test status. So these are the characteristics that are common to both ISO 9001 and CMM. It also includes some like training and services that have not included training and servicing, training and servicing, etc. Statistical techniques, etc. So these were the features that are common. So what is the contrasting things between the ISO 9001 and CMM is basically that should be our concern. So it includes there is we can say there is a strong kind of correlation between the ISO 9001 and the CMM, but on some issues they are not. There are things that are not covered in ISO 9000, and there may be some issues that are not covered in CMM. The biggest difference, however, between the two documents, because we need to prepare the both the documentation for both for ensuring the quality. So difference is that uh, CMM जो है, this CMM is focus on uh, continuous process improvement. So we can say the difference between ISO 9001 and CMM, we can say this is a continuous process improvement. This is continuous process improvement. But this is not a continuous, not a continuous process improvement. And biggest similarities, what you say, what say what you do what you say. The biggest similarity is every kind of feature that we have discussed, all those features are related in ISO 9001 and CMM. Now we'll have one poll here, and after that we'll tell you how to prepare the SRS document. So dash is a measure of time, but time between observed system failures. Next is which of the following are the aspects of failure: fault tolerance, fault failure detection, damage assessment, fault recovery, fault repair. So that is, uh, kindly answer these questions.
हाँ उधर से आवाज आ रही है।
Ankit, ending poll in 20 seconds. So, first question's answer is mean time to failure is a measure of time between observed system failures. Next is which of the following are aspects of fault tolerance? So all of these are the aspects of fault tolerance. So one, two, three, four, all applies to this. Next, these were the topics related to quality assurance that we have covered, and some of the topics left we'll discuss in the next class. Now, you need to prepare a in the practical part. You need to prepare a software requirement specification document. This is your experiment after project scheduling. Software requirement specification. Next is to draw the DFD using Microsoft View for any system, any system like university management system or railway tracking system or inventory system, any kind of system. Next is UML diagram you need to prepare in the next practical. So the three practicals are in line. First is the software requirement specification document, preparation of DFD 0 and 1 level, and third is the UML diagrams like class diagram, object diagram, use case diagram, and sequence diagram. You need to prepare four diagrams for your UML diagram practical that you need to draw in Microsoft View. For that, I'll send you video, one video for both the practicals for DFD as well as for the UML. But moving further for this software requirement specification document, I'm sharing screen here so that you can see how you are to prepare the software requirements specification document. So this is an example here. I am taking this example software requirement specification document with example. So what is basically a SRS document? You need to define what are the various specification. You need to write down the contents, table of content of your SRS document. You need to take a case study of any system. So you need to define the purpose, document conventions, project scope, references, overall description of the project, product perspective, and all these things. Next, you need to have system features, uh, functional requirements, external interface requirement, non-functional requirement in the SRS part, and also the purpose of particular document. intended audience and reading suggestion, कौन कौन उसको पढ़ सकता है, उसका scope क्या है, project scope, all these things. And in the product feature you can include the diagram like entity relationship diagram that can also be part of SRS document. User classes and characteristics you need to define. They have taken the example of this airline database system. So, what will be the operating environment, design and implementation constraints? क्या कौन से constraints होंगे उस system पे? System features and functional requirement, and if there is any kind of database, whether it's a distributed database or any kind of, how this will work as a client server system, interface requirements. You need to define everything in the SRS document. And ये आपने अभी मैंने आई हैव गिवन यू एन एग्जांपल, सो यू आर नॉट सपोज टू डू दिस एग्जांपल, किसी ने ये नहीं बनानी, बिकॉज अगर यू पीपल आर मेकिंग दिस एग्जांपल, आई surely reject that practical. This is just for your understanding. You can take the reference from this SRS document. You need to prepare your own document. Mind it, you need to prepare on your own document, and there should not be a copy in the class, copy of that document in the class. ये नहीं है कि चार बच्चों ने एक ही document बनाया था तो मैंने तो नेट से किया. No, no way. If you are taking help from the internet, it should be a help. It should not be totally copied from the internet कि दोनों बच्चों का सेम हो. You can take help and inculcate your own concepts and methods and your own knowledge in that SRS document. I hope this you can now make SRS document for this uh, another practical, that is DFD, that I had told you people that how to prepare the DFD. You can draw that diagram DFD in the using paper and pen. But for drawing in software, in computer system, you need a software called Microsoft Visio. I'm writing this in the chat box. Software name, that is install that software. It is available. I think on free on trial basis. So you can download the trial version and can use those simple tools for drawing the DFD. This is as simple as Word. आप जैसे वर्ड में कोई भी टेक्स्ट बॉक्स या कुछ भी लाइन ड्रॉ कर सकते हो, ऐसे ही आप वीडियो में भी कुछ भी सिंबल उठा के आप अप्लाई कर सकते हो. बट दिस इज जस्ट ए डिजाइनिंग टूल, और अदर थिंग्स विल बी डन ऑन योर साइड. आप पेपर पे पहले ड्राफ्ट बना लेना डीएफडी का and convert that into Microsoft View. And same applies to UML. For UML, you can have software like this Rational OS. This is a paid software. किसी के पास है इसका वर्जन कोई, ठीक है, लाइक किसी ने क्रैक्ड वर्जन है तो वो यूज कर लो. another is smart draft. This is also available on trial basis. So for Rational OS, Smart Draft and Microsoft Video are the designing tool software available for software engineering. तो आप किसी से भी टूल से यूज करके इसको बना सकते हो. If you are having any problem installing all these software, do tell me, बता देना मुझे. So I am ending this class here. Thank you student, thank you very much.